When dealing with PDC or PCC, you need to know that they're oxidizing agents. And what they do is convert an alcohol into an aldehyde or a ketone. And they can be used interchangeably. An oxidizing agent is going to increase the bonds with oxygen in another atom. So as you can see here, you have two bonds between oxygen and carbon, and where he has one here. And just to make it a little clearer, I can draw it like this. And what happens is you treat it with PDC or PCC, and you get this. The way that I like to visualize this on a test is the PDC or PCC is removing this hydrogen, which causes this bond to form a double bond here, and in turn causes this bond to kick off. And I'm aware that the hydrogen only has one valence electron, it can't hold two. But since other mechanisms that we deal with beta hydrogens work like that, it's just a way that I visualize it, and helps me to, when I first started doing these, helps me to understand what's going on. At least I can get the right answer for a test. So what if you have something a little more complicated? In this situation, you have more of an ethyl phenyl ketone, which is a secondary alcohol. If you add PDC to it, it's going to get the same result. You're going to get a double bond between the carbon and the oxygen. And then you're going to get this ethyl group on the bottom. So essentially what happens, these two hydrogens are removed, and you get the product here. So this is a ketone. So using PDC or PCC can form aldehydes or a ketone. Something you will more than likely see on a test when you do synthesis problems. But just to be clear, the jury is still out on PDC and PCC in terms of exactly how this mechanism works. It's just really something you have to memorize.